Greetings, friends. Here live on YouTube, we just have to wait until we get the feedback from the screen before we can record, especially if we want to record piano or ukulele, which is about to happen. So I see that we are in the flow now, and I can just mute this thing over here, and we should be good to go. All right, let me just hit record and we will dive in. Salutations from space and aloha from Earth, friends. Mercury is Cazimi. Let's look at a chart, shall we? Today is May 21st, 2022. Mercury currently aligns between us and the sun in the very first degree of tropical Gemini. So Gemini season has begun with sun's Gemini ingress, as it is every year. Well, how often might you find Mercury conjoining the sun, literally traveling between Earth and the sun in this degree, this first degree of a sign that often speaks of twos? Well, I want to talk about ones and twos and twos and threes and ones and fives and sevens and 12s with you today, because we're going to explore the harmony within Mercury's sacred geometry. I think you know the song, yeah? So where I want you to be right here is here. That's an out-of-tune piano. but even there, this octave will be the most consonant, the most settled, maybe even we could say the most agreeable interval between two notes. If I play something like this, not so much, a lot of tension, right? A little easier with the fifth or the fourth. And in fact, the fifth is said to be the most consonant interval besides an octave. So somewhere over the rainbow, begins with the octave. The octave, you hear the 8 in that word. Why? Because in a diatonic scale, imagine you've heard that sound before. The 8th note really is the octave of the first. So the 8 really is the 1. But let's hear 7 notes. 7 in astrology, oh right, the 7 planetas, the 7 visible lights, including the sun and the moon, Mercury, Venus, Mars, Jupiter, Saturn too. If we play all of the sharps and flats on the way between the 1 and the 8 or the octave, we're going to hear 12 actually. There's 12 and then the octave, which is the 1. Inside this piano, there's a hammer plucking a string when I do that. And there's another hammer plucking a different string when I do this. And there are 2 hammers plucking their own individual strings when I do this. And those 2 strings of an octave have a 2-to-1 relationship. A little bit easier to see outside of the piano box. If this was a grand piano, by the way, there would be 88 keys. Did you know that Mercury's orbit of the sun takes 88 Earth days? How many Mercury days might that be? Well, that's going to bring us to the 2 to the 1. So here's the string, right? And it is this long. I mean, as you can see, it actually goes a little bit longer, but this bridge cuts the vibration of that string off. So when I play that note, we're actually listening to the vibration of a wavelength that's carrying that entire string, right? Now the octave has me cut that string in half, which is here. You see how that is? That's the point right between this and that. So that's an octave, right? And the octave, which very visibly is half of the wavelength, is twice the frequency. All right, well, what does that have to do with Mercury, you might ask? Good question. Especially with Mercury Cazimi in the heart of the sun, in the sign of Gemini, which has much to do with things too, or at least things that are the two sides of one thing, like up and down or in and out, day and night. So 88 Earth days for Mercury to orbit the sun. But Mercury spins very slowly, very, very slowly. In fact, if you have a house on Mercury, your day is twice as fast as your year. Maybe that will land even better if we, instead of speaking of doubling, that's the octave, right? Double the frequency somewhere. What about halving the string to produce that 2-to-1 feeling, right? 1/2 the wavelength equals twice the frequency. On Mercury, the day lasts for, how do I want to say this right? Well, let me explain it this way and I'll try to figure it out. Let's say you have a house on Mercury and 1 year begins at sunrise. That entire year will last from sunrise to sunset. So half of a solar day, right? A solar day meaning sunrise to sunrise. Half of that time, just from sunrise to sunset. If the day and the night are equal in length, then okay, right? But half of the day is 1 year. From sunrise to sunrise, right? 1 solar day, 2 solar years have happened on Mercury. Say winter, spring, summer, and fall, but the seasonal dynamics on Mercury are going to be rather interesting and very different than what we're experiencing here. And of course, here on Earth, about 365 days or rotations per year or revolution of the light, right? What a trip. So for Mercury, it is literally 2 orbits per 1 spin with respect to the sun. Would you like to see the numbers? Sometimes I feel that is helpful. And I want to share this wonderful text. This is the great John Martineau's A Little Book of Coincidence in the Solar System, one of many incredible wooden books, John Martineau being the editor of that series at large. And here we are at NASA's planetary fact sheet. And I'm looking at Mercury, okay, and Earth. But let's just look at Mercury. So on Mercury, the length of day is this many hours. Maybe you should have written that in days. So let's take, and these are Earth hours. So let's go 4226 point, where is it? 6 divided by 60. That will tell us on Mercury the length of the day is, this length is actually 70 Earth days. And I want to do that again. 4222.6 hours. Oh, because I divide by the wrong number, right? 24 hours in a day. Okay. So you see that 176, right? 175.94 dot, dot, dot. Well, what happens if I divide that by 2? And we're going to get 88. Okay, 88 days being the length of the orbital period on Mercury. So Mercury takes 88 Earth days to get around that sun. And in that same amount of time, Mercury spins 1/2 of a rotation in respect to the sun. So if you're on Mercury, you've got this incredible octave, this 2-to-1 relationship. I mean, what's happening here, right? Notice that my left is going twice for every one over here with, this is my right. Feel that 2-to-1. 2. Now, if I sped that up to a point where it's like what you would actually hear is this. I mean, amazingly, polyrhythms, like even as simple as 2/1, are just very slow intervals, right? Can you see how the period of this hand, right hand, is twice or half as long as this one? That 2-to-1 relationship, that 2-to-1 frequency is the same as this 2-to-1 frequency, right? This vibration and this vibration. This vibration is twice as fast as this vibration, just as this vibration is twice as fast as this vibration. So if I could speed this up, and I can't fast enough, but with a computer I could, we would literally hear something like this. And if I could slow this down, it would sound like. So an interval like that, it really is the same exact thing as a polyrhythm. And this polyrhythm is like easy to hear, right? We're going to also get to this one, which is, also very digestible. That's this. Twinkle, twinkle, little Mercury. Okay, so in the 2-to-1, right? On Mercury, if you have a house on Mercury and a year begins as the sun is rising, that year will end as your sun sets. Because during one orbit of the sun, from Mercury's point of view, we have half of a solar day. So think about that, like during the course of 2 years, 1 year is daytime at your house, and 1 year is nighttime at your house. 1 year lasts from sunrise to sunset, and then next from sunset to sunrise. How Gemini is that? There's literally a light day and a dark day, or a day and a night day. Amazing. And this incredibly slow rotation of Mercury in respect to the orbital periodicity creates an experience on Mercury where the sun side of Mercury is just crazy hot, like one of the hottest places in our solar system besides the sun itself, where you don't want to go. Venus competes because she has this serious greenhouse thing going on. Mercury, no atmosphere, but Mercury's just very close to the burning sun, right? And so that solar side of Mercury, incredibly hot, while the night side of Mercury, not. In fact, I'm told that there's craters on the night side of Mercury that are colder than Saturn. Haven't been, can't tell you that from experience, but what an amazing thing, right? So very hot and very cold, night, day. I guess I should say hot day, cold night. right? These things are just so incredibly Gemini. So I thought I would share them with you here today with Mercury Cazimi in the first degree of that sign, the first degree of this sign that speaks in so many ways of twos or not twos. And here we go once again, 1 and 8, the octave, but the octave because this is twice the frequency, the amount of vibrations or cycles per second than this. So that 2-to-1 relationship is happening on Mercury for solar day in regards to solar year. All right. Well, the solar day and year on Mercury are not the same as the sidereal day and year. That's true on Earth as well. For Earth, our solar day is 24 hours, right? Sunrise to sunrise. It's going to happen for a little bit. Hey, it's Isabel. We're talking about Mercury, not Mars. We're talking about Mercury, not Mars. Right. So on Earth, a solar day is 24 hours, sunrise to sunrise. But a sidereal day, like star rise to that same star rising again, or a degree of a zodiac, like one Gemini until one Gemini rises again the next day, that sidereal day is 23 hours and 56 minutes. It's like we don't get that one here. Or maybe, yeah, you see the length of the day, 24 hours, but a rotational period, 23.9 hours. That's the sidereal day. Well, let's go at Mercury. We saw that the length of the day here is 4,222.6 minutes. Really much better to look at that one in hours as we did. And we saw it was twice that number of, well, Earth days for a Mercury orbit of the sun, which is 88, like the 88 keys on a grand piano. So we get this 176 days, or twice that 88 day period, Earth day period, for the length of a Mercury day, right? So one Mercury day is 176 Earth days. But a Mercury rotation, right? So this is a rotation with respect to the sun, solar day. With respect to a star, as you can see, it's much less. And in fact, I think what you'll see happens is if I take this number, I guess I'll just do it in Earth hours as it's written there. 4,222.6 hours. Let's divide that by 3. And you get this 1407.6, okay? So this is a 3-to-1 relationship. And let's just be there because for Hermes, so many things threes. I mean, at least for our experience here on Earth, every Earth year, Mercury will have 3 cycles. During each of those 3 cycles, Mercury will be retrograde for about 3 weeks, and this is Mercury's mudra, Mercury, Hermes, thrice grace, having the 3 parts of the philosophy of the whole world in Hermes' words from the Emerald Tablet. All right, so Mercury's rotation is, well, there's 3 rotations in respect to a star during each day, 1 rotation with respect to the sun. So that's an amazing thing. We get this 3-to-1. But remember that 1 rotation with respect to the sun has a 2-to-1 relationship with the orbit, right? So we can also look at the sidereal rotation. Here, 1407.6 hours. I'm going to turn that into days. All right, 58.6 or 58 and a half-ish. And what I want to show you is that this number here, 58.6, is 2/3 of this one, 88 days. Okay, so every 3 orbits, you're going to have 2 Mercury days with respect to the stars, not our star, the far away stars. Okay, so let's do that. Let's go 88 divided by 3 times 2. And we see that 58.66666, right? That's 2/3, 58 and 2/3, actually. Right, so if I multiply that, those are Earth days times 24 Earth hours. We'll find 1408 hours. So you see that 1408 hours, 1407.6 here. Super close. And once again, I learned these things from this little book of coincidence. Okay, so now we have 2/3. So we had the 1 to 2, which is the octave. Well, 1 to 3 halves, or 1 to 2/3, as we'll see, is the musical fifth. The next most settled interval, and therefore, by the way, the next most settled polyrhythm. Here's 2 to 1. Actually, I want to do it here. That thing wasn't snapping too well, so we better go here. Well, what about 3 to 1? Now we're all waltzing, right? But I want to go 3 to 2. Here, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. Or let's do it this way. Mercury, 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 Hermes, Hermes, Hermes. It's hard when you try to put words in with it too. Oh, not for me, it is for drummers. That's no issue at all. But hopefully you can feel that. Now, if I sped that up like super fast, it would literally sound like this. The musical fifth upon which all Pythagorean harmony is based. So that note, that interval here, that's not cutting the string in half, that's the octave. But here, if I cut that string into 2/3, right here's 1/3. And if I take twice that length, you'll see that this is 2/3 of the string length. So if I cut that string or that wave into 2/3, I have a frequency that's 3/2 the speed, really, right? 3/2 or 150%, that kind of thing, right? And that's Hermes, 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 Mercury, Mercury. I can't do it. I need to call in a drummer next time and a piano tuner. Anyway, there's this amazement in Mercury's Sacred Astronomy, literally the orbital dynamics, the rotation, and the orbital dynamics with the sun in respect to the rotation, in respect to the sun, and the rotation of Mercury in respect to the faraway stars, where we get Mercury's solar year orbit to solar day 2 to 1, Mercury year in respect to sidereal day rotation 2 to 3, the octave and the musical fifth, the most settled polyrhythms of 2 against 1 and 3 against 2. A little quadrivium, number magic, sacred harmony, sacred geometry, and sacred astronomy here for you on this blessed day with Mercury Cazimi in that first degree of Gemini. When will that happen again? It's going to be a bit. It will get close in 22 Mercury cycles, which is 7 Earth years. Because while Mercury, we can show this mudra, has about 3 cycles per Earth year. Cycles meaning synodic cycles from Earth's point of view with our sun. So Mercury coming between Earth and the sun 3 times a year. It's actually pi times a year. And of course, 22/7, an ancient ratio that we would use to get kind of close to that most magical number. Of course, Mercury pies. How incredibly Gemini. Thanks for spending some time, friends. I will see you in space.